Hello friends, welcome to TechSpace. Today we are going to discuss on the topic solar energy. Solar energy is radiant light and heat from the sun that is harnessed using a range of technologies such as solar power to generate electricity, solar thermal energy, and solar architecture. It is an essential source of renewable energy and its technology are broadly characterized as either passive solar or active solar depending on how they capture and distribute solar energy or convert it into solar power. Active solar techniques include the use of photovoltaic systems, concentrated solar power, and solar water heating to harness the energy. Passive solar techniques include orienting a building to the sun, selecting material with favorable thermal mass or light dispersing properties, and designing spaces that naturally circulate air. How solar energy works: solar energy is typically harnessed through photovoltaic PV cells or solar panels. These cells contain semiconductor material that absorb photons from sunlight, generating an electric current. The generated electricity can be used immediately or stored for later use. Benefits of solar energy: First, renewable. Solar energy is an inexhaustible resource as long as the sun exists. Second, environmentally friendly. It produces no greenhouse gas emissions or air pollutants during operation. Third, reduced electricity bills. Solar panel can offset or eliminate electricity costs for homeowners and businesses. Fourth, low operating costs. Solar systems have minimal maintenance requirements. Fifth, energy independence. Reliance on fossil fuels is reduced, enhancing energy security. Sixth, job creation. The solar industry creates jobs in manufacturing, installation, maintenance, and research. Challenges of solar energy. First, intermittency. Solar energy production is dependent on sunlight, making it intermittent. Second, high initial costs. The upfront cost of installing solar panels can be significant. Third, space requirements. Large installation may require extensive land or rooftop space. Fourth, energy storage. Storage solutions are needed to address energy production gaps during cloudy periods or at night. Types of solar energy technologies. First, photovoltaic PV systems convert sunlight directly into electricity using solar panels. Second, solar thermal systems use sunlight to heat a fluid, which is then used for space heating, water heating, or electricity generation. Third, concentrated solar power (CSP) focus sunlight onto a small area to generate heat, which is then used to drive turbines for electricity generation. Fourth, solar cooking utilizes solar reflectors or concentrators to cook food using sunlight. Fifth, solar water desalination converts seawater into fresh water using solar energy. Sixth, solar refrigeration utilizes solar heat to drive cooling systems such as absorption refrigerators. Integration with other renewable energy sources. Solar energy can complement other renewables like wind, hydro, and biomass to create a more reliable and consistent energy supply. Smart grids and microgrids manage the integration of these sources. Transportation. Solar energy is being increasingly integrated into various modes of transportation to reduce reliance on fossil fuels, decrease greenhouse gas emissions, and promote sustainability mobility. Here are some notable uses of solar energy in transportation. Solar power electrical vehicles (EVs). Solar panels can be integrated into the roofs, hoods, or other parts of electric vehicles to generate electricity while the vehicle is parked or in motion. This energy can be used to charge the vehicle's battery, extending its range and reducing the need of external charging. Solar powered charging stations. Solar panel installed at charging station can generate clean energy to recharge electric vehicles. These stations can be grid-tied or off-grid, providing renewable energy for EVs without relying solely on the electricity grid. Solar-powered public transportation. Solar energy is being used to power electric buses, trams, and trains. Solar panels on the roofs of these vehicles can help supplement their energy needs and extend their operational range. Solar-powered boats and ships. Solar panels installed on the decks or roofs of boats and ships can generate electricity to power onboard systems, lighting, navigation equipment, and even propulsion systems in some cases. Solar-powered aircraft. While solar-powered commercial flights are not yet common, there are experimental solar-powered aircraft that can fly using energy from onboard solar panels. These aircraft typically have large wings covered with their solar cells. The World Solar Channel. Development of a solar-powered car has been an engineering goal since the 1980s. The World Solar Channel is a biannual solar-powered car race where teams from universities and enterprises compete over 3,021 kilometers (1,877 miles) across central Australia from Darwin to Adelaide. In 1987, when it was founded, the winner's average speed was 67 kilometers per hour, that is 42 mph, and by 2007 the winner's average speed had improved to 90.87 kilometers per hour, which is 56.46 miles per hour. The North American Solar Challenge and the planned South African Solar Challenge are comparable competitions that reflect an international interest in the engineering and development of solar-powered vehicles. Solar flight. In 1974, the unnamed Astroflight Sunrise airplane made the first solar flight. On 29 April 1979, the Solar Riser made the first flight in a solar-powered, fully controlled man-carrying flying machine, reaching an altitude of 40 feet, that is 12 meters. In 1980, the Gossamer Penguin made the first piloted flight powered solely by photovoltaics. This was quickly followed by the Solar Challenger, which crossed the English Channel in July 1981. In 1990, Eric Scott Raymond in 21 hops flew from California to North Carolina using solar power. Development then turned back to unmanned aerial vehicle (UAV) with the Pathfinder 1997 and subsequent design, cul- culminating in the Helios, which set the altitude record for a non-rocket propelled aircraft at 29,524 meters, that is 96,864 feet, in 2001. The Zephyr, developed by BAE Systems, is the latest in a line of record-breaking solar aircraft, making a 54-hour flight in 2007, and month-long flights were envisioned by 2010. From March 2015 to July 2016, Solar Impulse, an electric aircraft, successfully circumnavigated the globe. It is a single-seat plane powered by solar cells and capable of taking off under its own power. The design allowed the aircraft to remain airborne for several days. This is the first house to have solar panels. Architecture and urban planning. Sunlight has influenced building design since the beginning of architectural history. Advanced solar architecture and urban planning methods were first employed by the Greeks and Chinese, who oriented their buildings towards the south to provide light and warmth. The common features of passive solar architecture are orientation relative to the sun, compact proportion, a low surface area to a volume ratio, selective shading, overhangs, and thermal mass. When these features are tailored to the local climate and environment, they can produce well-lit spaces that stay in a comfortable temperature range. Socrates' Magoran House is a classic example of passive solar design. The most recent approach to solar design uses computer modeling, trying together solar lighting, heating, and ventilation system in an integrated solar design package. Active solar equipment such as pumps, fans, and switchable windows can complement passive design and improve system performance. Urban heat islands (UHI) are metropolitan area with higher temperature than that of surrounding environment. The higher temperature results from increased absorption of solar energy by urban materials such as asphalt and concrete, which have been lower albedos and higher heat capacities than those in the natural environment. A straightforward method of counteracting the UHI effect is to paint building and road white and to plant trees in the area. Using these methods, a hypothetical cool communities program in Los Angeles has projected that urban temperature could be reduced by approximately 3 degrees Celsius at an estimated cost of $1 billion, giving estimated total annual benefits of $530 million from reduced air conditioning costs and healthcare savings. Agriculture and horticulture. Agriculture and horticulture seeks to optimize the capture of solar energy to optimize the productivity of plants. So, agriculture and horticulture. Agriculture and horticulture seek to optimize the capture of solar energy to optimize the productivity of plants. Techniques such as timed planting cycles, tailored row orientation, staggered height between the rows, and the mixing of a plant variety can improve crop yields. While sunlight is generally considered a plentiful resource, the expectation highlights the importance of solar energy to agriculture. During the short growing seasons of the Little Ice Age, French and English farmers employed fruit walls to maximize the collection of solar energy. These walls acted as thermal masses and accelerated ripening by keeping plant warm. Early fruit walls were built perpendicularly to the ground and facing south, but over time sloping walls were developed to make better use of sunlight. In 1699, Nicolas Petio de Durer even suggested using a tracking mechanism which could pivot to follow the sun. Applications of solar energy in agriculture, aside from growing crops, include pumping water, drying crops, brooding chicks, and dyeing chicken manure. More recently, the technology has been embraced by vintners who use the energy generated by solar power to power grape presses. Greenhouse converts solar light to heat, enabling year-round production and growth. In enclosed environment of specialty crops and other plants not naturally suited the local climate, primitive greenhouses were first used during Roman times to produce cucumber year-round of the Roman Emperor Tiberius. The first modern greenhouses were built in Europe in the 16th century to keep exotic plants brought back from an exploration abroad. Greenhouses remain an important part of horticulture today. Plastic transparent materials have also been used to similar effect in polytunnels and row covers. Fuel production. Solar chemical process use solar energy to drive chemical reaction. This process offsets energy that would otherwise come from a fossil fuel source and can also convert solar energy into storable and transportable fuels. Solar induced chemical reaction can be divided into thermochemical or photochemical. A variety of fuels can be produced by artificial photosynthesis. The multi-electron catalytic chemistry involved in making carbon-based fuels such as methanol from reduction of carbon dioxide is challenging. A feasible alternate is hydrogen production from protons. Though use of water as the source of electron as plants do, required mastering the multi-electron oxidation of two water molecules to molecular oxygen. Some have envisaged working solar fuel plant in coastal metropolitan area by 2050. The splitting of seawater providing hydrogen to be run through adjacent fuel cell electric power plant, and the pure water byproduct going directly into the municipal water system. In addition, chemical energy storage is another solution to the solar energy storage. Hydrogen production technologies have been significant area of solar chemical research since the 1970s. Aside from electrolysis driven by photovoltaic or photochemical cells, several thermochemical processes have also been explored. One such route used concentrators for to split water into oxygen and hydrogen at high temperatures, 2300 to 2600 degrees Celsius or 4200 to 4700 degrees Fahrenheit. Another approach uses the heat from solar concentrators to drive the steam reformation of natural gas, thereby increasing the overall hydrogen yield compared to conventional reforming methods. Thermochemical cycles characterized by the decomposition and regeneration of reactants present another avenue for hydrogen production. The Solzing process under development at the Weizmann Institute of Science uses one MW solar furnace to decompose zinc oxide (ZnO) at temperature above 1200 degrees Celsius, that is 2200 degrees Fahrenheit. This initial reaction produces pure zinc, which can subsequently be reached with the water to produce hydrogen. Energy storage method. First, thermal mass system can store solar energy in the form of heat at domestically useful temperature for daily or interseasonal duration. Thermal storage systems generally use readily available material with high specific heat capacities such as water, earth, and stone. Well-designed system can lower peak demand, save time of use to off-peak hours, and reduce overall heating and cooling requirements. Second, phase change materials such as paraffin wax and rubber salts are another thermal storage medium. These materials are inexpensive and readily available and can deliver domestically useful temperature approximately 64 degrees Celsius or 147 degrees Fahrenheit. The Dover House in Dover, Massachusetts was the first to use a global salt heating system in 1948. Solar energy can also be stored at high temperature using molten salts. Salts are an effective storage medium because they are low cost, have a high specific heat capacity, and can deliver heat at temperature compatible with conventional power systems. The Solar 2 projects use this method of energy storage, allowing it to store 1.44 terajoules, that is 4 lakh kWh, in its 68-meter cube storage tank with an annual storage efficiency of about 99%. Third, off-grid PV systems have traditionally used rechargeable batteries to store excess electricity with grid-tied systems. Excess electricity can be sent to the transmission grid, while standard grid electricity can be used to meet shortfalls. Net metering programs give household system credit for any electricity they deliver to the grid. This is handled by rolling back the meter whenever the home produces more electricity than it consumes. If the net electricity use is below zero, the utility then rolls over the kilowatt-hour credit to the next month. Other approaches involve the use of two meters to measure electricity consumed versus electricity produced. This is a less common due to the increased installation cost of the second meter. No standard meter accurately measures in both directions, making the second meter unnecessary. Fourth, pumped storage. Hydroelectricity stores energy in the form of water pumped when energy is available from a lower elevation reservoir to a high elevation one. The energy is recovered when demand is high by releasing the water, with the pump becoming a hydroelectric power generator. Water treatment. First, solar distillation can be used to make saline or brackish water potable. The world recorded instance of this was by 16th century Arab alchemist A large-scale solar distillation project was first constructed in 1872 in the Chilean mining town of Los Salinas. The plant, which had solar collection area of 4,700 meter square, 51,000 square feet, cloud produced up to 22,700 liters, that is 5,000 MP gal, and 6,000 US gal per day and operate for 40 years. Individual still design including single slope, double slope or greenhouse type, vertical, conical, inverted absorber, multi-beck and multiple effect. These stills can operate in passive, active or hybrid modes. Double slopes still are most economical for decentralized domestic purpose, where active multiple effect units are more suitable for large-scale applications. Second, solar water disinfection (SODIS) SODIS involves exposing water-filled plastic, polythene, terephthalate PET bottles to sunlight for several hours. Exposure time vary depending on weather and climate from a minimum of 6 hours to 2 days during fully overcast conditions. It is recommended by the World Health Organization as a viable method for household water treatment and safe storage. Over 2 million people in developing countries are use this method for their daily drinking water. Third, solar energy may be used in a water stabilization pond to treat wastewater without chemical or electricity. A further environmental advantage is that algae grow in such ponds and consume carbon dioxide in photosynthesis. Although algae may produce toxic chemicals that make their water unusable. Concentrated solar power. Concentrated solar power (CSP) system uses lens or mirror and tracking system to focus a large area of sunlight into small beam. The concentrated heat is then used as a heat source for conventional power plant. A wide range of concentrating technologies exists. The most developed are the parabolic through the solar tower collectors, the concentrating liner Fresnel reflector, and the Stirling dish. Various techniques are used to track the sun and focus light. In all of these systems, a working fluid is heated by the concentrated sunlight and is then used for power generation or energy storage. Design need to account for the risk of a dust storm, hail, or another extreme weather event that can damage the fine glass surface of solar power plant. Metal grills would allow a high percentage of sunlight to enter the mirror and solar panel, while also preventing most damage. So this is Vanguard 1, a solar power satellite. So let's know about this. Vanguard 1, Harvard designation 1958, Beta 2, COSPAR ID 1958-002. This an American satellite that was the fourth artificial Earth orbiting satellite to be successfully launched following Sputnik 1 and Sputnik 2 and Explorer 1. It was launched on 17 March 1958. Vanguard 1 was the first satellite to have solar electric power. Although communication with the satellite were lost in 1964, it remains the oldest human-made project still in orbit, together with the upper stage of its launch vehicle. Vanguard 1 was designed to test the launch capabilities of a three-stage launch vehicle as a part of Project Vanguard and the effect of the space or environment on a satellite and a system in Earth orbit. It also was used to obtain geodetic measurements through orbit analysis. Vanguard 1, being small and light enough to carry with one hand, was described by the Soviet premier Nikita Khrushchev as the "grapefruit satellite". So, Charles Fritz, a New York inventor, created the first solar cell in 1883 by coating selenium with a thin layer of gold. The cell achieved an energy conservation rate of 1 to 2%. Fritz's solar cell was capable of producing continuous electrical current. The world's first rooftop solar array using flat selenium cells was installed in 1884 on a New York City rooftop. Thank you for watching. If you enjoyed this video, please give it a thumbs up and share with your friends. And don't forget to subscribe our channel and hit the bell icon on. Thank you.